Hi guys. Okay, so we've been doing equations for a long time now, right? So we're going to move on to what happens when you have variables on both sides of your equation. So I'm going to call this variables on both sides. Might take a little bit for my camera little system to catch up here. Okay, anyways, so let's go ahead and write down a potential example of this. So here's number one. So we're used to seeing things like 5x minus 3 equals 12. Goodness gracious, the lag is so annoying. Okay, so this is a normal equation to us. We would add 3 to both sides, divide by 5, and we got it. So what we're looking at today is what happens if there's also a variable on the right-hand side of the equation, such as like plus 2x. Okay, so what do you do when this happens? Well, your game plan needs to be that you need to get all your variable terms to one side of the equation and all the constants, which are your regular numbers without variables, to the other side. Okay, now some math teachers will argue that, put your variables to the left, to the right, whatever. I always put my variables to the left because in my final answer, I want my variable on the left, right? So here's what I would write. I'm going to write some like steps or notes off to the side. Move the terms with variables to one side. And then when I say move, I'm literally talking like, I don't want 2x to be over there. I want to move it to the left. I want it to be with the other variable term. But how can you do that? How can you mathematically, like legally move a 2x? Well, you're going to use inverse operations. So using inverse operations. Now, we've heard that phrase before, and we've been using inverse operations all throughout the equations topic, okay? So here's what I mean by that. I want this 2x to be moved over with the other variable term, which is the 5x. So I want to move it to the left-hand side. I can do that legally. That's why I love equations, is I can do whatever the heck I want to as long as I do it on both sides, right? Remember, it's a teeter-totter. So if I want to add 500 elephants on this side, that's fine, as long as I add 500 elephants on that side, right? You can add, subtract, multiply by anything you want on equations as long as you do it to both sides. So if I want to move this 2x, if I no longer want it on the right side, I can make that happen. Since it's a positive 2x, I'm going to subtract 2x. Okay, well, let's separate our sides, keep this organized. Whatever I do on one side, I have to do to the other. Now, am I going to write minus 2x under the 5x or under the 3? What makes more sense? I hope you said the 5x, right? Because those are like terms, so we stack them up, okay? Now the 2x minus 2x, that is going to cancel. Make sure you know why. 2x minus 2x is 0, okay? 5x minus 2x is 3x. And then I'm going to drop down everything else. Okay, so this now looks like a regular equation to us. Well, let's go ahead and write what we're doing right here. So we moved all the terms with the variables to one side of the equation. I always choose to move mine to the left. Technically, you could move it to the right. You just have to flip your answer around at the end, okay? And then after you move the terms with variables to one side, you're going to move the constants to the other side. Using inverse operations. Sorry for my messy handwriting. Okay. All right, and that's normal to us. We're used to doing this whole add 3 thing. Really what you're doing is you're putting the constants together on a side. Okay, we just didn't phrase it like that before. So I'm gonna move this 3 to the other side. How I do that is I use inverse operations. Since it's a -3, I'm gonna add 3. Whatever I do on one side, I have to do to the other. -3 plus 3 cancels out to 0. I'm left with a 3x over there. 12 plus 3 is 15. So I now have 3x equals 15. We know what to do, I hope by now. Obviously, we need to get that x by itself. So what's that fancy word for getting something by itself? Isolate. So our last step over here is to isolate the variable. Now, how do we isolate it? It's not magic. What do we use? We use inverse operations. Isolate the variable using inverse operations. Okay. So what we mean by that is since x is timesing by 3, I'm going to do the opposite. I'm going to do the inverse of multiplication of 3, which is division of 3. Whatever I do on one side, I do to the other. 3 divided by 3 is 1, and 1x is just x. 15 divided by 3 is 5. Okay? So really there's only one new thing here, which was that first step we did. We moved a term with the variable on it. We are really comfortable, adding 3 to both sides, dividing by 3 on both sides. We're fine with that, but sometimes kids freak out and go, can we do that? Can we add a variable to a side? Yeah, remember, you can do whatever the heck you want to in equation land as long as you do it to both sides. That's the golden rule, okay? Now, if you're like, I don't really trust you, Miss Meineke, you are doing some crazy voodoo magic here. Well, let's go ahead and check this. Let's check. This is where checks are super important, is when you have variables on both sides, okay? I'm going to rewrite this equation, except for anywhere there's an x, I'm now going to plug in my answer of positive 5. So I have 5 times positive 5 minus 3 is supposedly equal, notice that question mark, to 12 plus 2 times our answer. Now, all I'm seeing is if the left side actually simplifies to the right side. So I'm just going to simplify the left, simplify the right, see if they equal each other. On the left side, I have to do multiplication first. 5 times 5 is 25. Let's go to the right side. I got to do our multiplication. 2 times 5 is 10. On the left side, let's simplify that down one more time. 25 minus 3 is 22. And 12 plus 10, 22. Does 22 equal 22? Yes, it does. Since that checks out to be a balanced equation, we know that our answer of x equals 5 was absolutely correct. Okay? And that should make you feel good. Like, ooh, did that right. Okay, let's do some practice ones. So really the only thing that's new today, guys, is you're going to have a variable term that you plus or minus on both sides. Okay? Put your variables together on one side, constants together on the other side. Here's number 2. -5 plus x equals 7 minus 3x. Okay. All right, so I gotta move my variables to one side. Now, it doesn't say left or right. That's because it's your choice. I typically always choose to move my variables to the left because at the end, don't I want the x on the left anyway? That's my feelings, okay? Other teachers have different opinions on it. So like me, I first look at this negative 3x and I'm like, ooh, I want that to be on this side with its friend, okay? Since it's a negative 3x, I'm going to use inverse operations and I'm going to add 3x. But whatever I do on one side, I have to do to the other. Now, this is where I just get bugged by this. Kids like to put plus 3x underneath this 5. Are you kidding me? They're not like terms. That doesn't make sense to stack them up right there. You need to put that plus 3x under x because they're like terms. Makes sense, right? So the 3x's over there, they cancel to 0. X plus 3x is 4x. And then I'm going to drop down the negative 5. This was a positive 4x, so I put a plus, equals, and then I drop down the 7. So now I have negative 5 plus 4x equals 7. This looks like a typical equation to us, right? So we're going to extend this down a little bit, keep things organized. I want to move this constant of negative 5. I want to move it to the other side, but if I'm going to move something to the other side of the equation, I have to be using inverse operations. Since it's a negative 5, I'm going to add 5. The 5's cancel. I'm left with 4x. 7 plus 5 is 12. And then there's just one last move. We got to isolate that variable using inverse operations, of course. X is times by 4, so what are you going to do? You're going to divide by 4 on both sides. Keep it balanced. 4 divided by 4 is 1. 1x is just x. 12 divided by 4 is 3. X equals 3. Okay. Next up, number 3. 5y plus 18 equals 8y. Okay. So I want you to look at this. Left side has a variable and a constant. The right side only has a variable term. There's no constant there. So typically, I like to move my variables to the left. It's typically my game plan. But in this case, if I were to follow my heart here and try and move this 8y to the left, what would be left over on that right-hand side? It would be nothing. And we've talked about this. You don't want to just like chop off an arm, right? You don't want nothing on one side of the equation. Some of you know, okay, I could put 0 and continue on, and that's fine, okay? If you are, I don't know, smart enough to realize that the value would be 0 and keep solving from there, that's okay, I'm fine with it. But I just want to show you that it's okay to move your variable terms to the right. It's okay. It bugs me, but it works. So let's, on this one, move our terms with variables to the right. If I wanted to do that, I would subtract 5y on both sides. Because you're still getting your variables to one side, and that's the whole game plan, right? So this cancels to nothing, cancels to 0y, which 0 times y is 0, right? Cancels to nothing. I'm left with 18, and then 8y minus 5y is 3y. Okay, I don't want 3y, so I'm going to divide by the coefficient there. I'm going to divide by 3 on both sides. 18 divided by 3 is 6. And I'm left with y over here. And then this is what I mean. You just have to flip it around. If 6 equals y, my final answer is y equals 6. Okay. So obviously we can plug these in and check them, and you're welcome to do that on those. I'm going to make you do it on the next 2 anyway, just for practice. Okay. If you think you're getting the hang of this, I would recommend on questions 4 and 5 to try it without me. Okay. So to pause the video after I write it, try it without me, and that way you can check. Okay. Here is number 4. 3y minus 10 equals 4y minus 6. You want to get your variables to one side, constants on the other. If you're feeling okay, I recommend stopping the video right now, trying it out, then push play. Okay, so I always like to put my variables on the left most of the time. So I'm looking at this 4y thinking, I'm going to move you. How I do that is I'm going to subtract a 4y. Since it's positive 4y, I'm going to subtract 4y so that it cancels to nothing. Whatever I do on one side, I do to the other. 3y minus 4y is negative 1y. You don't really need the 1 there. You could write negative y. That's fine. I'm going to drop down the minus 10, drop down the equal sign, and drop down that negative 6. Okay, so I have successfully moved my variables to one side. Now I need to move my constants to the other side. So I need to move this negative 10. Since it's a negative 10, I'm going to, of course, add 10. Whatever I do on one side, I have to do to the other. 10s cancel out. I'm left with negative 1y. Negative 6 plus 10 is positive 4. And then this y, I don't want negative 1y. Let's get rid of it. And divide by negative 1 on both sides. And I get a final answer of y equals negative 4. Okay, so let's practice your check. Maybe you already did this without me, but let's make sure you know how to do your checks because it's ultra important when we get into these bigger equations. It's important that you know how to check well. So I'm just going to plug in my answer of negative 4 in both of these spots up top. So 3 times negative 4 minus 10 hopefully equals 4 times negative 4 minus 6. I know this is crowded, sorry. Okay, so let's just simplify that left side down real quick. 3 times negative 4 is negative 12. On the right side, we have to multiply 4 times negative 4 is negative 16. Simplify that left side. Negative 12 minus 10 is negative 22. Negative 16 minus 6. 16 plus 6 is 22, so negative 22. And since it's balanced, we know our answer is right. Okay. Same thing on number 5. If you're feeling like maybe you're getting this, I recommend stopping the video after I write it. Try it out without me. Negative 8x minus 5 equals negative 2 minus 2x. I'm going to move this variable term to the left. It's usually always my game plan. Since it's a negative 2x, I'm going to add 2x so that it cancels. I'm also going to add 2x on the left side, of course. Negative 8x plus 2x is negative 6x. Drop down everything else. Okay. Now I'm going to move my constant to the right-hand side. Since it's a negative 5, I'm going to add 5 on both sides. And I'm left with negative 6x equals something. Negative 2 plus 5 is positive 3. Excuse me. Since x is timesing by negative 6, we're going to divide by negative 6. Ooh. I'm hoping you didn't write negative 2 as your answer. 3 out of 6, that's a fraction. So let's simplify it. 3 out of 6, that's half. Don't forget the negative. You should get negative half. Can you write it as negative 0.5? Absolutely. It's the same thing. It's a decimal version. Okay, I'm going to squeeze in my check right here. Sorry for the mess. Okay, so I'm going to plug in negative half wherever x is. And don't freak out about half. Half is a pretty easy number to multiply by. So I have negative 8 times negative half minus 5 hopefully equals -2 minus 2 times our answer of -1/2. It's sloppy, I know it is. Okay. Negative times negative, positive. 8 times half, what's half of 8? 4. So over on the left, you have 4 minus 5. On the right-hand side, I got to multiply real quick. I'm going to drop down this -2. This -2, though, is being multiplied by -1/2. So a negative times a negative is a positive. So we'll know we're adding. 2 times half, well, half of 2 is 1. Okay, simplify the left side. 4 minus 5 is -1. -2 plus 1, -1. Woo, we're balanced. We're good to go. Okay, now, I don't know why I'm excited to show you these, but these are weird things. I want you to write careful in your notes. The things I'm about to show you don't happen often, but they happen every once in a while. These are kind of some weird equations. Weird things are going to happen here. So here is the equation. 4x plus 3 equals 4x plus 5. Now, if you just look at that, just like think about that, 4x added to 3 is the same as 4x added to 5? Is that even possible? Well, maybe we're not really paying attention and we're just going to start solving like normal. That's fine. Let's see what happens. I want to move my variable term to the left, right? That would be my game plan. Since it's a positive 4x, I'm going to subtract 4x. Cancels right there. And then I go right here and go, 4x minus 4x cancels over there also. So what are we left with? Well, that's a 0, but I don't have to write the 0 because there's something over there. There's a positive 3 on the left, and there's a positive 5 on the right. But you need to ask yourself, does 3 equal 5? No. So you need to put a slash through that equal sign. This is a rare case, but it can happen. If you notice that your variable terms cancel completely on both sides, then here's what you need to look at. If what's left over is a true statement, it's one answer. If it's a false statement, then it's a different answer. So what I mean by true and false, does 3 equal 5? No. So I want you to write on your page, false statement. Okay, and definitely put that slash through that equal sign. 3 does not equal 5. Since it's a false statement, here's what you would actually write for your final answer. You would write no solution. Okay, the word solution. I use it every once in a while, but solution just means answer. Okay, so like right here, the solution for x was -1/2. The solution on y for y was -4. So my solution was -4 here. Solution just means answer. So when this happens, when your variable terms cancel out and you're left with a false statement, then what you write is no solution. And what that means is there's no answer for x that makes the equation true. It's kind of impossible. There's no answer. There's no answer. X can't really be anything that makes this equation true. Okay, let's look at another kind of similar example. 10 plus 2x equals 2x plus 10. Now, if you just analyze that real quick and go 10 plus 2x, 2x plus 10, that's just like switched around. Maybe you're just having a day and you don't notice that right off the bat. And so you're like, I'm just going to solve like normal. Move my variables to the left. I'm going to move this 2x here. So I'm going to subtract 2x on both sides. You go to cancel, and then you go right here and you go, whoa, 2x minus 2x? Nothing. Once again, our variables have canceled on both sides. Now, sometimes it results in a true statement, sometimes a false statement. So let's see what we're left with. I'm left with a 10 on the left, and I'm left with a 10 on the right. So does 10 equal 10? Is that a true statement? 10 equals 10? That's true. So this, I want you to write true statement. Okay. So if it comes out to a false statement, if your variables cancel on both sides and you're left with a false statement, then you would write no solution. But if you're left with a true statement, you would actually write infinite solutions. Infinite means like, you know, infinity and beyond. There's no cap on how many solutions there are. Any number that you plug in for x would be a true statement. So let me show you. Let's say x is 100. If you plug in 100 right there, 2 times 100 is 200. 200 plus 10 is 210. So we'd have 210 on that side. I plug in 100 there, 2 times 100 is 200, plus 10, 210. It's going to be balanced. If you plugged in -5, you'd end up with 0. -5, you'd end up with 0. You're always going to end up with a balanced equation no matter what number you plug in for x. And some people, instead of writing infinite solutions, I like infinite solutions because it's like the opposite of no solution. I don't know. You might also see it like this, guys, all real numbers. It means the same thing as infinite solutions. It means all real numbers that you plug in for x are solutions, okay? Okay, so these don't happen often, but they happen sometimes, and it is needed for higher level math, so I want to expose you to it now, okay? But I'm going to give you 2 practice problems. You're going to solve these before class, okay? Here's number 8. -x plus 7 equals -4x minus 20. Number 9 is 10x minus 3 equals 6x plus 25. Okay, so just to reiterate, these no solutions and infinite solutions happen sometimes, not always. It's only going to be these weird ones when your variable terms both cancel out, okay? But these ones you'll get an actual answer for. That's my hint to you. Okay, so go ahead and solve those. I recommend checking them as well, and that way when we're on Zoom, you can plug them in feeling confident. Okay, thanks guys.